Hello everyone, this is a video lecture for Pre-Calculus section 7.5. Just more trig equations. There is literally nothing new here. Also remember, just like the last time, the 2 pi k stuff, use k as an integer and stuff like that. Nearly all of the problems use it. I think there's only like 2 that might not. We'll see them as we go. Cosine of 2 theta is equal to cosine squared theta minus 1/2. Solve for theta. So first off, I'm confused because what is that doing in with these guys? We have to convert it with a formula. If you go to your formula sheet and go to those double angle formulas and stuff like that, you should be able to find that this is 2 cosine squared theta minus 1. That's one of the options to choose. I chose that one because now I've just got a whole lot of cosines, and they're all squared. I don't have any sines, so there's no need to put all that in there. This looks good to me. I like this. I'm going to subtract this to the other side, like that. I'm going to add this 1 to the other side. So I got 2 minus 1 is 1. And then 1 minus 1/2 is 1/2. When you square root both sides, remember, plus or minus, and this, we've already talked about how this works out. It'll be the square root of 2 over 2. Again, I'm looking for my x value. And it's both positive and negative, as long as it's got something to do with square root 2 over 2. Well, of course, that's going to be 45 degrees. And every single variation of it. So real quick, as an answer, we've done the exact same problem, I'm sure of it. At this point, this is exactly what we've already seen. The new stuff is all this, use a formula to get the answer kind of thing. So pi over 4 plus 2 pi k, 3 pi over 4 plus 2 pi k, 5 pi over 4. Plus 2 pi k, and 7 pi over 4 plus 2 pi k. Now, they will have an answer, their WebAssign answer is actually much quicker. Pi over 4 plus pi k over 2. And that's it. That's all they got. They're saying that as long as we got our one answer here, I can add a quarter rotation, a quarter rotation, a quarter rotation, quarter rotation. So again, 2 pi, and I'm going to cut it into 4 equal parts makes a pi over 2, and that's how they got that little piece right there. Okay. So yeah, much easier to type, but you also have to think like that. And again, as I've already stated, I don't think like that very often. I don't try to, I guess, ultra simplify it or something. I just do it until I get an answer. Type it in, no simplifying. That's just the kind of guy I am, I suppose. And I'm sorry that you're stuck with me. So moving on. This is one very interesting equation. I don't even know where to start with this stuff, and that's the fun part about this. I'm going to move this over, I suppose. And I remember that cotangent is actually 1 over tangent. Notice I just put in the denominator. If I multiply that over to the other side over there, I could have to say it's squared. Square root both sides. So I got a plus and minus. Remember, square, you got a plus and minus. Square root of 3. Well, again, yes, I've seen square root 3 on my unit circle somewhere, I think, but every time it's divided by 2. And so what I'm going to do is divide it by 2. Notice that this is going to be my y value. This is my x value. We're talking about tangent here, okay? Y over x. And so I'm looking for whenever my y value is going to be bigger. Any variation plus or minus is everything's fine. So up here at 60, 120, 240, and 300. Here, I'll write it out in degree land so that you have it. Okay, those are my 4 answers. And so, of course, full answer here, I would say then pi over 3 plus 2 pi k. Well, 2 pi over 3 plus 2 pi k. Not 3 pi over 3, but 4 pi over 3 plus 2 pi k. And 5 pi over 3 plus 2 pi k. Okay, awesome. Next one. 75015. I've got tangent of theta plus 1 is equal to secant. Now let's just pause on this problem. I was looking through the notes here before I started this recording, and I saw the method that I used, and I did not like it. I didn't like it. I flipped the page, and I looked at my answers that I had, and I did not like them. Did not like it at all. So what I'm going to do instead is I'm going to do a different method. I'm going to show you something here, but in the end, it's still not perfect. I went and did it a different way, and it was still not good. But I guess it's going to be okay. So I'm going to do it the long way. I'll show you the quick way here in a second. But both are not perfect. And I'll show you what we should do about this problem at the end. I'm going to square both sides immediately. I do this because it looks something like a Pythagorean kind of thing. It looks kind of Pythagorean. And it's, yes, kind of. The thing is with the square, you can't distribute the square. Not like that, at least. That does not work. It means there's two entities of that. Therefore, I have to actually manually multiply like that. So tangent squared plus 2 tangent theta plus 1 is equal to secant squared. Now, this part and this part together look very similar to this guy with the Pythagorean identities. And as far as I remember, again, I'm trying to remember all of them. There's a lot of different formulas. I'm pretty sure, I know this is my recording. I should probably go back and verify later, that this is one of those formulas, okay? Tangent squared theta plus 1 equals secant squared. I'm gonna pause for a second and verify. Okay, I was correct. Here, I pulled it up. This guy right here. So tangent squared plus 1 plus tangent squared is equal to secant squared. Okay, so I verified. Sorry I had to pause it, but, well, you know, it's better to go and check now than later. What I'm trying to get at is that these two components look very similar to this. I'm just gonna be very, very, very slow about this for just a whole minute here, okay? So I'm just gonna put them in a different order. I just basically said all these guys kind of go together. Well, I know that this is equal to secant squared. And then I'm going to say, well, guess what? I can minus secant squared on both sides. Huh, go figure. Do not like that. Sorry, it's just a button on my little stylus thing. So I got 2 tangent theta is equal to 0. That's it. Now, that's kind of too basic almost in a way. You could divide by the 2 even. I've got tangent theta is equal to 0. That's 0 degrees. That's 0 radians we're talking about here, okay? I'm saying my slope is equal to 0. Where's that happening? It's right here, right there, at 0 and pi. And so my first initial answers is going to be that, with the 2 pi k, of course, 0 plus 2 pi k, and then pi plus 2 pi k. That's my initial answers. And in fact, it's wrong. At least I'm 90% sure it's wrong. My paper here says it's wrong. So what is going on here? I mean, I thought it was pretty clear. Well, something about this problem is just a little weird, and I'm just going to tell you that we should double check our answers all the time. I don't do that every single time, but I should. What I want to do is, in particular, verify those two answers that I got, 0 degrees and 180 degrees, okay? Or again, 0 and pi. You can use, the radians if you like. I just want to see if these work in the original. So then what I have is tangent of 0 plus 1 is equal to secant of 0, okay? 0 radians, 0 degrees, whatever you want to use. They're the same at this point. Well, tangent at 0, the slope is 0, plus 1. Secant at 0, again, we're thinking this is 1 over cosine of 0. Remember that, okay? And so my cosine of 0 is actually a 1, and so then I got basically 1 over 1. So is 1 equal to 1 over 1? Yeah, that's awesome. Okay, well now let's do it for the 180. So I'm going to say tangent of pi plus 1 is equal to secant of pi. Let's see if this one works. Well, tangent of pi, again, the slope at 180 degrees is 0, as I was thinking. Remember that this is cosine, 1 over cosine, and my cosine at pi, my x value at pi, is actually a negative 1. Is 1 equal to 1 over negative 1? Now I would say no. That's a no. So that one actually doesn't work. My only answer is this 0 degrees thing, or again, 0 radians. And so my final answer, remember the 2 pi k, 0 plus 2 pi k. And that's it. That's your whole answer. I know that's kind of weird, and you might be thinking, well, how did that happen? Why do I have to double check myself here? And, you know, what other problems would I have to do that? I think it might be from the very beginning. Right here, the very first step, notice what's going on is that I'm squaring both sides. What if I had a plus and a minus here? What if my original had a negative, let's just say? Well, it's gone now. That thing is gone. So it's like I'm erasing some of my answers, or I'm adding answers that weren't there, perhaps. Who knows? I'm just saying that I could have had a negative or positive, who knows, and now it's gone. Now, I only really wanted a positive in order for it to work, but it's like when you go backwards, it doesn't always translate, okay? It's like two different languages. You go from English into, say, Spanish, and then all of a sudden you want to go from from Spanish into English. The translation's not always perfect. I mean, that's just, I don't know, one example. I don't know Spanish, but I mean, there are other cases where you translate it back and forth a couple times, and even Google Translate won't even do it right. So, just a thought there. Okay, can I show you the quick way? Real quick. I know I'm taking way too long on this thing, but this is just another way of seeing this problem. I don't know if I recommend this or not, though. Honestly, it's going to end up the same in the end. I saw this as a sine over cosine. It's kind of a basic, I don't know what to do with this problem, let me just try something kind of answer. I want a common denominator. So I'm going to say this is cosine over cosine. So I'm skipping about 2 steps right there. And what I did on my paper is I canceled. And I was thinking, you know what's interesting? I had this huge talk with you on the last section about not canceling. Instead, you should be factoring and stuff. And yet I went and did it. Well, let me just show you what I keep going with here, okay? Because, I mean, it still kind of works-ish. I say, okay, now what do I do? Well, now I'm going to square both sides because I have no clue what else to do. But I've seen a lot of sines and cosines that are squared, and they should maybe cancel or something. Well, these guys right here actually are equal to 1 together. And so I've got 2 sine theta cosine theta plus 1 equals 1, and those guys cancel. 2 sine theta cosine theta is equal to 0. You can actually, like what I did not do this. I divided by the 2. Yeah, I divided by the 2 and cancel it. But this guy right here is actually sine of 2 theta is equal to 0. That's a kind of a weirder one to solve. I'm saying that my angle A, whatever that is equal to 0. And so my sine, actually this might be the correct way to do it now. And then I'm thinking, I didn't do this step on my paper. I just immediately said, oh, divide by 2 and start solving some other way. This might actually do something good. I'm saying that my sine is equal to 0. That's this guy and this guy. 0 and 180. Okay, so I got that far. But that's my A. That's my A. Okay? And I'm saying that my A is equal to 2 theta. Okay? So let me rewrite it. 2 theta is equal to either 0 degrees or 180 degrees, right? But now, if I divide by 2 on both sides to get theta, because that's what I want, I got 0 over 2. I got 180 over 2. Nah, this is still bad. See? So those are my two answers that are possible. Well, we already tested that the 0 works out. 0 degrees is great, but now what about the 90 degrees? So let's plug it back into the original, see what happens. So I got tangent pi over 2 plus 1 is equal to secant pi over 2. Again, I'm spending way too long on this problem, but again, you could have put your pencil down and you can skip ahead on the video, whatever you got to do. It's interesting here, tangent at 90 degrees is actually undefined. Plus 1, and my secant is going to be a 1 over 0 again, which is now still undefined. So is undefined plus 1 equal to undefined? I mean, I don't know. we don't talk like that. So just basically none of this is working, and you don't do that. You just don't. So you don't have that guy. You only have the 0. Yada yada yada. All right. Spent way too long on that problem. Let's keep moving. 75020. I mean, it's a good lecture. It's good to talk about these problems. But honestly, if you were just trying to get the answer, you should have stopped a long time ago with me. So to get this guy here, my first thoughts is to move the 1 over and divide by the 2. Now notice this 3 theta. We saw that on the last problem. This is going to be an even better representation of what's going on here. So let's talk about this. This will be great problem to talk about. Rather than 3 theta, because I don't even know how to read that, I'm going to replace it with angle A. Angle A. And again, remember that this is a positive. So we got a y value as an angle A whenever I have a positive 1/2 for my y values. My y value being positive 1/2, that's a smaller amount, so it's going to be over here and over here. This is going to be, again, at 30 degrees and 150 degrees. Okay? So my answers then, so far, is that A is equal to pi over 6 and 5 pi over 6. Okay? Cool. I like that. Well, A is equal to 3 theta. And so then I'm going to divide by 3 on both sides. And so what I actually get, 3 times the 6 is 18. And then if I put another 3 in there, I get another 18. Okay, cool. Yeah, awesome. I love it. So then, of course, I'm going to go and put in my final answer, right, with the 2 pi k stuff. I love when this stuff happens. Be ready for it. Watch out. Here we go. You ready? You ready? Oh, man, I was writing in pen. Stop that. I feel like almost you should watch the video to the end first and then go back and take notes. Because you know I'm going to be that kind of guy. That is incorrect. Why? Why is that incorrect? Yes, these are true for the first revolution. But as you keep going, it's not going to be a full revolution anymore. Basically, I need to see this right here, these answers up here, with the 2 pi k. So instead, what I really should do is say 3 theta is equal to this guy plus 2 pi k and 5 pi over 6 plus 2 pi k. And you're saying, well, I put the 2 pi k in. What's wrong? Well, hold on. Divide by 3 on both sides, and what happens is that you get, yes, this pi over 18, but notice here, it's now 2 pi k over 3. Did you see that? This revolution detector is a little different, okay? 5 pi over 18, true, plus 2 pi k over 3 now. This is your true answer, okay? So, a lesson learned, I suppose. Keep cruising. 75031. I got 3 tangent cube theta plus 3 tangent squared theta minus tangent theta minus 1 equals 0. What? Can I put this in a calculator? I don't think you can, honestly. So what do we do? Well, I'm looking at it, and I see some a format that I've seen before somewhere. In fact, these guys here, they have some commonalities. And here too. This is factor by grouping. These guys are in one group. They both have a 3 in the front. They both have at least 2 tangents. Leaving behind tangent plus 1. On this side, they both have a minus sign. Tangent plus 1. Notice, factor by grouping, you must have these two factors here identical. You must have them the same. If you don't have it, factor by grouping doesn't work. I'm going to put a 1 right here just in case. Invisible 1. I'm going to factor these guys out to the front. Tangent theta plus the 1. Oops. Now times the leftovers. 3 tangent squared theta minus 1 is equal to 0. Notice that these guys just kind of fell down. I now have 2 separate answers now. Over here on this side, tangent is equal to negative 1. That's easy. On this side, I'm going to move the 1 over and divide by the 3. Tangent squared theta is equal to 1/3. Remember, when you square root both sides, what do? Plus and minus. Now, of course, we're all super excited to see this, but we've done this before. Remember that I'm adding some 2's in there, that those 2's would cancel. They would bring it back to the original here. But I want to see this because I've seen this in terms of y over x. My y values are 1/2. My x values are bigger at the square root 3 over 2. When is my slope equal to negative 1? And what's going on here is negative 1 is this way. This is going to be negative 45 degrees, or again, that would be the 315. Over here, this is the 135. Yep. So those are my 2 answers on that side. On this side, again, I'm looking for my smaller y values, my bigger x values, and again, every single negative positive possibility. So bigger x values are this guy at 30, 150, 210, 330. Notice that this is part of my memory tools. I'm saying x is the bigger one. It's 0.866 rather than 0.5 for my y. So I already know I'm going to go more x. Therefore, I'm going to have, like, way over on this side, that's a small little angle, 30 degrees. And once I have this guy, again, I only memorized the first quadrant. Once I have 30 degrees, I go, oh, it's 30 degrees everywhere. Again, plus and minus, because any variation of that should be okay. 6 answers. Now, thankfully, there wasn't any, like, 2 thetas or something like that. You don't have to actually divide or something in the end. So let me just start listing them out. And I know you know that there's way easier ways to type this. This is the 3 pi over 4, 7 pi over 4, yeah. I know there's way easier ways to type it all out. You do that. You do you. I'm going to do me, okay? What I'm doing is I'm just going the long route here. But I know the long route. I'm comfortable with the long route. Me and the long route, we get along. We hang out on the weekends. Yes, it's just the lecture experience you're getting here. Okay. Not as professional as some of my other recordings, but hey, you know what? It's the math, the material that matters. Again, if you were wanting to be fun and quick about it, you could say, oh, I'm going to start right here and say plus pi k plus pi k. You could start right here and say plus pi k plus pi k, and you can start right there and plus pi k plus pi k. Now, what you can't do, I'm going to use a different color, what you can't do is say this plus this amount over there, and somehow it's okay. Because then you'll add that same amount, and you'll end up like down here, and then you'll end up like over here maybe. You see, like, and those are not angles, those are not answers. You can't just add this. It's almost always going to be plus pi k or plus 2 pi k Or if you actually had like a 2 theta or a 3 theta, then you would divide those by 2 or 3 or whatever it was, okay? Moving on. 75044. I've got tangent of theta over 2 minus sine theta is equal to 0. Solve for theta. I'm confused. This guy, what? And so I go to my trig identities page here, and I got this, what is that big old formula thing going on there? What I don't have written is the WebAssign Quick version. It's not on here, okay? And I like this new WebAssign Quick version. I hadn't seen it before doing this, using this book. So, I mean, I've been teaching other books, of course, and they never use this, so as far as I saw. But this is an awesome little formula. I mean, this guy is literally, they're equal. That's an equal sign. This equals that. There it is. Very convenient. Very simple. Not big square roots and all that craziness. Okay, so this is now your revised formula. Look, all sines and cosines. That's pretty neat. These both have a sign, so I'm going to factor that out to the front, leaving behind 1 over 1 plus cosine theta, and that's a minus 1, and then equals 0. On this side, I'm saying that sine theta is equal to 0. My y value is equal to 0. And on my unit circle, it's going to be here and right there. Okay? 0 and pi. On this side, it's a little bit more work. I'm saying that I got this expression here is equal to 0. Move the 1 over. I'm going to multiply this to the other side. The 1 just kind of disappears at that point. Minus 1 on both sides. So I'm saying my cosine is also equal to 0. That's my x value. So my x value is equal to 0. Or, there's a big or right between them. Or my y value is equal to 0. Where's my x value equal to 0? Right here, straight up at pi over 2. And straight down at 3 pi over 2. So I got 1, 2, 3, 4 answers. Turn the page. And so I start going crazy on it. You ready? Oh, you should watch to the end. So I add my plus 2 pi k to every one of my answers. Of course, I could probably simplify this down anyways. Okay, cool. Why is this one wrong? There is only a couple problems that say use answers from my 0 to 2 pi interval. Basically 1 revolution, square brace, parentheses, all that stuff. Just use answers from the first revolution. That simplifies it. So I put these guys in. And again, I only got 1 more attempt. How am I going to do this problem? What am I going to do? What's wrong with this? Oh no, I'm freaking out. What do I do? Well, I got nothing else better to do but just to double check stuff. So tangent of 0 over 2 minus sine of 0. Does that equal 0? So tangent of 0 is equal to 0. Sine of 0 is equal to 0. Cool. Okay, let's keep moving. Tangent of pi over 2 minus sine of the pi over 2. Is that equal to 0? Well, this is tangent of pi over 4. That's 45 degrees. My slope is a 1. It's a fancy 1 is what that is. Fancy 1. My sine at 90 degrees, my y value over there is a 1. So yeah, that works out too. Okay. I got tangent at pi over 2 now. Pi was my thing I plugged in. Minus sine of pi is equal to 0. Well, notice tangent at 90 degrees, my slope is straight up. This is undefined. I guess later on you'll say infinity. infinity. This guy's a 0, so is infinity minus 0 equal to 0? No, as long as you get an undefined, it's no good at all. So this guy's no good. Go up to my answers there. Oh, well, I'll just cancel it out here in a second. Finally, try the last one. Over 2. 3 pi over 2. I guess I don't have to do a crazy fraction for this guy. It's good enough. That's 3 pi over 4. That's going to be -1 slope, essentially, at 135 degrees. My slope is -1. This guy over here is straight down, so -1. Notice that I got a +1 minus 1 is equal to a 0. That is correct. So my real answers, you should always double-check your answers. Always. Oh, I did it again, didn't I? No, just remove that answer and you're good to go now, okay? Always double-check, right? You're always double-checking your answers. Of course you are. Every single problem, you put it in a WebAssign, you're like, I don't know, WebAssign, is it really real? Is it really good? And they're like, yeah, green check mark. And you're like, I don't trust you, WebAssign. I have to check it for myself. That was a joke. Don't do that. Just move on. How do I solve this guy right here, right? What do I do here? First off, I want to convert this over. There's quite a few formulas for that. I'm going to use something with just a lot of cosines in it. So 2 cosine squared theta minus the 1. There's two other formulas that you can use. I just want cosines everywhere. Distribute. Two negatives make a positive. Do not cancel these two guys. No, no, no. They actually combine when you add them to the same side to make a 4 cosine squared. And then 2 plus 1 is, well, a 3. So that's kind of different. Divide by the 4, of course. Okay. I'm going to square root both sides. Remember, whenever you square root, you got to have a plus and minus. So the square root of 3 and the square root of 4, you can break them up, obviously. Square root of 3, that's not going to change anything. But the square root of 4 is actually a 2. I'm saying that my x value is equal to plus or minus this guy. Notice that square root of 3 over 2 is the bigger one. So I'm saying more x, more x, more x, more x. 30 degrees and all of his friends. And so, yet again, I'm going to give you the little hint here. They say use the 0 to 2 pi business. When they say this, that's happy days, right? You only have to type like the first couple of answers in the first revolution. Later on, that's actually going to be a small hindrance because we're going to have like a 3-something angle, and then you're dividing by 3, but then there's still more inside the first revolution. It gets a little sticky sometimes, but if we're just kind of taking these basic problems here, it should be fine. So there we go. That was good. One last problem, 75066. This is kind of, I thought that this was a word problem of some kind. It's dealing with harmonics or something. I don't know. The meat of the problem is math. So we have this formula where here it's dampened. It's basically, over time, it's kind of just going towards 0. But it's still creating that harmonic motion. Okay, so damped harmonics, I think is what it is. We're trying to solve for t when it's equal to 0. I'm going to tell you, this guy right here has nothing to do with anything. This is this times this, right? A times b are 2 factors. Is this guy here ever equal to 0? No? All right, get rid of him. He's always a positive. He might be small, but he's never equal to 0. This is really your only concern to finding that 0. So I'm saying that sine of 2 pi t is equal to 0. Well, I know that sine of 0 is 0 and all that kind of stuff. Rather, let's just look around. Y values being 0 right here, right here. Yeah. So 0 degrees, 180 degrees, 360 degrees, and so on and so forth. So I'm saying that the angle on the inside here, let's call it angle A. My angle A is 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, whatever they need. I don't know how. We'll just keep going. Well, I'm going to replace that with 2 pi t. Notice that I wrote out like way too many answers here. This is actually how you're supposed to do a problem like the last one here. But let's say they had like a 3 right there in the end, and you had to still solve. So you would say like 3 theta divided by 3 and all that kind of stuff. I would keep going this way like I'm doing now, so that I can acquire all of the answers within this revolution. It's not these temporary answers within a revolution. I'm saying the final answers within a revolution. So if you had a 3 right here, I would actually say this stuff here, I would keep going again. That's 1, 2, and then I would do it a third time. Like, I know that sounds really weird, but the next guy after this one would be 13 pi over 6. Notice that I'm just going to the next. I guess he would be coterminal right here is what I'm saying. 13 pi over 6. And I would keep going, and I would keep going, and I would keep going. And then I take all this, divide by 3, and I should be able to get everything I would originally have in the first revolution. Now, thankfully, we don't actually have to do that on these problems right now. I'm just warning you, so if you do see something like that, maybe I skipped it, I don't know. I certainly don't want to skip those kind of problems, but I've seen them before. I want to just mention it. So I went really far out here. Same thing. I don't know what's going on. I just keep going till whatever. And then I'm going to divide by the 2 pi on both sides. And so then 0 over 2 pi is that. Notice pi's are going to cancel, leave a 1/2. I got a 1. I got 3 halves. And you can start to see the pattern as you keep going. 2, 5 halves, 3, 7 halves, blah, blah, blah. Well, what they're wanting, I believe, is the first 4 answers. That's all I have. I have 4 answers. That's supposed to be a star. Close enough. And so it would be 0, half, 1, 3 halves. Okay, cool. That's it. That's all I got. Thank you very much. Have a great day.